Good morning all, welcome to today's class. In today's class, we'll be solving a problem that is related to Jamb 2026 possible question. It's a question that is likely to be asked in Jamb 2026 because each year Jamb do select questions that do come out in electricity or in cells. Alright, so let's look at the possible way to solve this problem. Okay, remember that what we are doing today is Jamb 2026 possible questions. Alright, so we have 3 cells of EMF 1.5 volt and internal resistance 2.5 ohm are connected as shown in the diagram below. So this is the diagram below. Find the net EMF and the internal resistance, where we have the options, option A, option B, option C, option D. So take note of the question. The question says 3 EMF, that's 3 cells of EMF. So we are given 3 cells of EMF 1.5 and internal resistance. If you look at the diagram, you will notice that this is your first cell, your second cell, and your third cell. And then this is the first internal resistance, the second internal resistance, and the third internal resistance. And then the question answer are connected as shown in the diagram below. So if you look at this diagram, you know that this is a diagram in parallel connection. And then find the net EMF. We have to find the net EMF, the EMF, the electromotive force, the EMF, and the internal resistance. So we'll be using this diagram to find the EMF and the internal resistance. All right, so let's figure out the EMF. Now you have to take note one, since the diagram is showing us a parallel connection. That means that for us to find the EMF, you need to take note of what happens when you have a parallel connection. When there is a parallel connection of the EMF, we have one, that the total cell is equal to the first cell and equal to the second cell and equal to the what? The third cell. So the total cell is equal to the first cell, equal to the second cell, and equal to the third cell. That means that if the first cell is 2, the value of the second cell will be equivalent to the first cell. And if the second cell is 2, the value of the third cell will be equivalent to what? The second cell. That means that in parallel connection, the cell, the voltage, the potential difference have equal value. So here we have that the total cell is equal to E1, equal to E2, equal to E3. And what is the cell given? We have that the cell given is 1.5 volts. So that means that if I have that E1 is 1.5 volts, that means that this will be 1.5 volts and E3 will be 1.5 volts. Therefore, we can have that our E total is equal to 1.5 volts. So that's the answer for the cell. Then we still have for the internal resistance. How do we calculate for the internal resistance? Now, calculating for the internal resistance, still take note that this is parallel connection. And since it is parallel connection, that means that we have 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3, which implies that 1 over R is equal to, what's our first R? We have 3 cells of EMF and internal resistance. 3 cells. So that means that in these 3 cells now, we have that the first resistance will be 1.5. The first resistance will be 2.5. That's the first resistance will be 2.5. The second resistance will be 2.5. The third resistance will be 2.5. But when it comes to the cell, we have the first cell will be 1.5. The second cell will be 1.5. The third cell will be 1.5. So we have 3 cells of EMF, 1.5 volts. Another value for the internal resistance, which is in 3 places, which is 2.5 ohm. So we have that the value for the internal resistance is 2.5 ohm. The value for the second, 3. it appeared in 3 places. Since we have it appearing in 3 places, we're going to have 1 over 2.5 plus 1 over 2.5 plus 1 over 2.5. So what are we going to do now? Since they have a common denominator, I'll sum up the numerators. So I'll have 1 plus 1 plus 1 will give me 3. So I'll have 3. Then take a common LCM. That will be 2.5. That will be 2.5. Then I have this 2.5. Then since I have 2.5, look at what I'm going to do. I want to have 1 over r is equal to 3 divided by 2.5. Now, for us to find r, remember that what we're looking for is the internal resistance. For us to find r, we have to cross multiply. So cross multiplying, we'll have 3 times r, which is 3r, is equal to 1 times 2.5, which is 2.5, and then divide by 3. Dividing by 3, we have this. So that will give us r as 0.83 ohm. So this is the answer for the internal resistance. So remember that what we did at the first place was to note that when you have a cell, that's your voltage, your potential difference, your EMF, provided that the connection is in parallel, that each of the cell will be equivalent. You don't add in parallel connection when it comes to the cell, that's the EMF or the voltage or the potential difference. So we have that traces of EMF 1.5 volt is given. So this is the EMF. So that's 1.5, 1.5, 1.5. But we don't have to add it. Why? It is in parallel connection. Since it is in parallel connection, we now equate the value. That means that the total EMF is equal to E1 equal to E2 equal to E3. And then when I have for the resistance, in parallel we'll have 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3, which then implies 1 over R equal to 1 over 2.5 plus 1 over 2.5 plus 1 over 2.5. You now take the common LCM, which is 2.5. Why? There is 2.5 here, 2.5 here, 2.5 here. So we'll have 2.5 here. And then we'll have 1 plus 1 plus 1. So we'll now have 3. So that will be 3 divided by 2.5. So since we have 3 divided by 2.5, bring it out. So now have 1 over R equal to 3 over 2.5. So R will now multiply 3. That's cross multiplying. We'll now have 3R. Then 1 times 2.5, we'll now have 2.5. Divide both sides by 3 to have R. We'll now have 3 cancel 3 will give us 1. And then 2.5 divided by 3, we'll now have 0.83 ohm. So that's the answer. So the answer to this is option D. Option D is the answer. Thank you for watching. Keep posted as we post more of our videos in YouTube. We'll be posting more of the possible